This video will give you more information on the ANOVA assumption of independence of errors. There are three primary ANOVA assumptions, and all of them are in relation to error, where error is determined by comparing the expected value to the observed value. And error then is determined by how far is your observed from what is expected. So all three of these primary assumptions for ANOVA really are concerned with the error that is calculated for your observed distribution. So the first one is independence. And here we want to look at, are all of these errors independent of each other? Are they independently distributed? Meaning that the error from one individual point or one group is not causing the error in another individual or another group. The second one is normality. And just like looking at normality of your continuous variables, we're doing the same here, but for the errors and the distribution of errors. So you want your normality to indicate that you have a normal curve of errors. And lastly, we have homogeneity of variance. And homogeneity of variance is really looking at the distribution of errors for each of the populations or each of the groups represented is the same, and that there's not a variation across the groups. So this way, when we look at is any particular treatment or whatever our outcome is and how that outcome is being impacted, how does that variance shift between the groups? Because that shifting of variance is what shifts the means to be able to compare those means and see if there's statistical differences. So it's important for the differences in the groups to not be from the violation of homogeneity of variance, but to actually be from a shift in the variance, thus a shift in the. For the independence of errors, you're really looking at the distribution of the errors and then testing to see if being in a particular group is changing the level of error. And you don't want the level of individual error to be changed by what group they're in. Because if they're in a particular group and that changes their error levels, it means that the observed value for that group is very different than the expected value of that group. That's where that error is coming from. And if that's occurring, then it's very difficult to be able to compare those mean differences and the shifts in variance across the groups, because you don't know if it's the inflated error for one or more groups is what's causing the differences between the groups. To really assess the independence of errors for an ANOVA analysis, you could use just logic in understanding what the groups are and why one particular group may have more error or an inflated error over another. Or you could use the interclass correlation formula. And this interclass correlation formula really looks to see if being in a particular group changes or inflates the error that is assumed with each individual. And we have to remember that any ANOVA analysis is going to assume that your errors are random and they're independent across all of your individual observations. And so if you have a violation of this independence where any one of the groups has an inflated error, it's going to also inflate the p-value. And that's where we can have some problems with this independence of error. If this is a concern, there's a pretty easy fix for independence of errors in that you can change your alpha level or your significance level to be more stringent, and make sure that you, even with an inflation of the p-value from this violation of independence of errors, you're still obtaining statistical significance. So instead of using a 0.05 like we usually would, you can use a 0.01 or a 0.001.